everyone. This is your classwork for, it says 1021, but it's actually 1021 and 1022. I was just too lazy to add that because I had already downloaded this to write on. Also, I got some new headphones, so hopefully these ones won't make weird ringing sounds in the recording. Okay, quick reminder, if you didn't already, make sure you turn in your Systems of Equations Graphing with Zombies paper from last week. If you're an online student, you haven't turned it in yet, please take a picture of it and send it to me. That would work best. For today and tomorrow, you're going to need the Systems of Equations notes, the printed notes that I gave you a couple weeks ago. And then you might need your notebook, pen and pencil, and a calculator. Okay, we're going to continue talking about systems of equations. So I wanted to just briefly remind you what systems of equations are, since it's been over a week. Hopefully everyone had a good fall break, by the way. Okay, so systems of equations. Basically, this is when we have a set of equations that have the same variables, so they can be graphed on the same plane, right? So we have two equations, both of them have x and y and x and y, right? We could graph them on the same plane. Whereas if you had something like, I'm just making this up as I go. If you had something like that, we would not call them a system of equations because they have different variables and we couldn't graph them on the same plane. Okay. Okay, system of equations. We talked about this last time too. Again, this is just kind of a refresher. A solution to a system of equations is going to be the ordered pair, so the x and the y. That is the solution to all equations. So if you have two equations, you're only going to have, in most cases, 1 point, one ordered pair, that will be the solution to both of those equations. Any other pair will not be a solution for both equations, in most cases. So let's take a look at the exceptions to that. Okay. Oh, there's my dog. Oh, hang on, guys. Let me just get control of my animals. I guess I should say. No momento. All right. Okay. Somebody in the neighborhood just started using a microphone and they're blasting their voice for some reason. My dog wasn't too happy about that. Okay. Anyway, systems of equations. If we have two equations, so two linear equations that can be graphed on the same plane, like these ones, there will be only one solution, meaning one ordered pair, that will make both of the equations true. So if you plugged those numbers in for both of the equations would be true. Hopefully that makes sense. You can also have no solution with systems of equations. In this case, you would have two perfectly parallel lines. Okay. There could also be infinite many solutions if we have two lines that are overlapping. Okay. Most of the time, you'll end up with just one solution to the system of equations if they are linear equations. Okay. So we're going to go over, last time we went over graphing, solving systems of equations through graphing. The reason I want to go over the two other ones, substitution and elimination, is because sometimes when we're graphing and trying to solve systems of equations, it gets a little dicey or shady when we're trying to figure out the exact point that they intersect. So let me just draw a couple lines real quick. Okay, so if we take a look at these lines, we know they intersect right there, okay? But looking at the graph, let me zoom in a little so we can see this up close. Looking at the graph, it's very hard to tell exactly what this number would be on our x-axis. And it's also difficult to tell what this number would be on our y-axis, right? We could estimate and maybe just like round it to this line and this line, okay? But if we need precise answers, not just estimates of solutions, we would need to find exact numbers. To do that, graphing isn't always the best option, which is why we're going to go over substitution and elimination. Today we'll do substitution, eliminations for tomorrow. Let's see here. So, substitution. These notes are in that notes packet that I printed for you guys a couple weeks ago. So you should have this. If you ever get stuck when you're working on the individual problems later, always just look back to that page that has these notes on it. Okay, tells you exactly how to solve systems of equations with substitution. Some of the wording's a little weird though, and you might not quite understand what it's talking about. So we're going to go over a couple examples. I'm just going to go over the steps super quick, and then we'll do the examples. Let's go with this. So step 1, if possible, and if it's not already like this, you're going to solve at least one of the equations for one of the variables. So in other words, you're going to want something that looks like this. Y equals something, or X equals something, or A equals something. And just one of the equations is fine, okay? One of the variables in one of the equations. The next thing we would do once we've done that is substitute that result, so this part, substitute that result, an arrow, into the other equation to replace that variable. Okay, so in other words, if we, let's say we had the equation, let's say we have that, and in our other equation, we solved for y and got this quantity here, okay? What it means by substitute that result into the other equation to replace that variable is something like this. You're going to find where the y is because we're looking at y here. And you're going to rewrite the equation so that instead of the letter y, basically you're just going to replace it with the quantity that you got from solving for y in the other equation. Okay. This will make a little more sense once I'm putting actual numbers in there, but this is just to give you a general idea. From there, you're going to solve the equation because at this point, we would only have one of the variables in the equation. So you could solve for x, for example. The next step would be to substitute the value you just found into the first equation and solve for the other variable. So what I mean by that is hopefully once you've solved this, you're going to have some answer that looks like x equals something, okay? That number you're going to substitute into the original equation. So the first one, the first equation referring to that guy. Actually, you could do it in either equation, and it would work. And basically just solve for y. So you'd end up with something like y equals, I don't know, instead of maybe, or I'll illustrate this, instead of x, let's use a different color, instead of x, you would write whatever number you just found for x. So 3 times whatever number x is plus 4, and then you solve for y. And then you end up with an x and a y, and that solution you would write as an ordered pair, x, y. And that would be the only pair of numbers, of x and y numbers, that would make both of the equations true. Again, a lot of that was kind of abstract because I wasn't dealing with actual equations and numbers, but hopefully that gives you a general sense of what direction we're going. Okay. Let's see here. We're going to do some examples. Okay. All right, our first example, I'm actually going to rewrite it. I'm going to rewrite it over here just so I have more space. I'm going to rewrite them in different colors too. 16 and okay. So we have our system of equations. We know it's a system because they both have x's and y's. So we could graph them on the same plane. We're going to follow the steps from the other page. So our first step is going to be solve for a variable in one equation. Okay. All right. So let's maybe, you can choose either equation, but I'm going to choose this one right here. Okay, so I'm going to rewrite it below. And you can choose either variable to solve for. It doesn't really matter. In this case, I'm going to choose to solve for y. Okay, so the first thing I'm going to do, I'll write the steps out in maybe a different color. First thing I'm going to do is add x. And again, there's multiple ways to do these problems. So if you weren't thinking of doing the exact same thing that I just did, no worries, because we could still end up in the same spot. Okay, so when we add x to a negative x, we get 0. So on that side, we're left with, that's a weird 4. We're left with 4y equals x minus 16. Okay, the x was positive because we were adding it, and the 16 is negative, so we're subtracting it. We still need to get y by itself though, so right now it's being multiplied by 4. We would divide by 4. Okay, and the tricky part here is remembering that in front of that x is the invisible 1, right? If we have any number or letter and we multiply it by 1, it's just itself, so it's just that invisible 1 there. Okay, so what this would end up being, if you look at the first part of the equation, the left half of the equation, we have 4y and we're dividing by 4. Well, 4 divided by 4 simply gives us 1, and 1 times y is just y. On the other side, though, we have a 1x divided by 4, right? We can't really simplify that unless you want to do a decimal, which is totally fine, but we could just write it as the fraction 1 over 4 because of that invisible 1 by the x. 1 divided by 4 times x. And then we have negative 16 divided by 4, which would give us negative 4. And if you're confused on how I got that answer, I would go back to one of the previous videos on solving equations, and that'll maybe refresh your memory on that. Okay, so now that I've solved for y in this equation, what I'm going to do is basically take my first equation, and instead of writing y there, I'm going to replace that y with this entire quantity in parentheses. Okay, so let's do that. We're going to have 7x plus 4 times y, which now we know that y equals 1/4 x minus 4. So let's write 1/4 x minus 4 equals 16. Okay, so if that doesn't make sense how I got that, just remember that we just solved for y in one of the equations. Since they both have y and they can both be graphed on the same plane, well, this quantity of y, we can substitute in for this y. It'd be the same as saying, well, we solved an equation and y is equal to 3, right? We could substitute 3 into the equation and solve for x. Okay, it's the same thing, it's just slightly more complicated because we have 1/4 times x minus 4 instead of just one number. Okay, so from here, I kind of skipped writing some of the steps out, but let's see. Solve for one of the variables. Yep, we did that. This right here is, let's see, step 2, which was substitute result into other equation. Just want to make sure y'all know what I'm doing and why. And then third step would be solve that equation for the other variable. So in this case, move up just a little bit and then I'll zoom out so you can see the whole thing when we're done. So in this case, we're solving for x because now we don't have any y's in the equation. We have 7x plus 4 times 1/4 x minus 4 equals 16. So there's no more y's. We're just solving for x now. So we would do it just like we would do any multi-step equation solving for x. The first thing I would want to do is, and again, you can do this multiple ways, but the first thing I would personally want to do is distribute that 4. Okay, let me actually do that in a different color. Gonna distribute that 4 to both things inside the parentheses. So I'm gonna end up with 7x plus 4 times 1/4. If we do that, we'd get 4/4, which is the same thing as saying 1, right? 4 divided by 4 is 1. So we would have 1x, or you could just write x. Either way is fine. And then 4 times -4 would be -16. Equals 16. Okay. From here, we want to combine our like terms. Our like terms in this case are going to be the x's and the non-x's. Oh, Jen, come here, buddy. You're okay. Will there ever be a video of Miss Monson that doesn't involve dogs? Nope. Okay. So let's combine those. 7x plus 1x. 7 plus 1 is 8. So we have 7 of something and 1 of something. We combine them together, we have 8 of something. In this case, that something is x. So we have 8x. And then to get rid of the 16 on that side, since we're subtracting 16, we're going to do the opposite and we're going to add 16 to both sides. 16 plus 16 gives us 32. Hopefully now you're like, I got this, Ms. Monson. You don't need to rattle on. But you're just going to have to deal with me rattling on anyway. Okay, so now we have 8 times x equals 32. We need to get x by itself. So because it's being multiplied by 8, we would divide by 8. And we would be left with x equals 4. Okay, so I'm going to kind of highlight that because that's important information that we'll turn back to in just a second. So here's where we're at so far. We solved for a variable in one equation, substituted the result into another equation, solved that equation for the other variable, and now, drum roll please, we substitute that value in to equation and solve for other variable. Now what I mean by other variable is the one that we don't know now. We know x is 4, right? So we know x, we don't know y. So we're going to solve for y. Now you could do it to either equation. You could substitute that 4 in for x in either equation. In fact, why don't we just do it to both, just so you guys can see. Okay, so we know that I'm actually gonna I'm gonna put that. That was fantastic, Jenna. Okay, I'm gonna substitute the 4 now in purple, just so you can see it highlighted, into both equations and solve for y. Okay, so let's start with maybe the first one, 7, and instead of x, we have 4 plus 4y equals 16. So now we're just going to solve for y. We have 7 times 4, that would give us 28, plus 4y equals 16. Now we need to get y by itself, so we're going to get rid of the thing that's being added first, right? SADMEP, PEMDAS backwards. Get rid of the addition and subtraction first. So we have a positive 28. We would need to subtract it to get to 0 there. Okay. Maybe I'll just scoot this over so you're not annoyed by all that crap on the other side. Not crap, it's great, it's math. Oh, lordy. Okay, 4y equals, and we have 16 minus 28. Now you're like, come on, Miss Lawson, don't you know this off the top of your head? I'm thinking about it. Took me longer than it should have, but it's fine. Okay, equals negative 12. And to get the y by itself, it's being multiplied by 4 right now, so we would divide by 4. And again, if you're lost in how we're solving these equations, I would go back to one of the previous videos we've done in this class that talks about solving equations. Okay, 4 divided by 4, that just cancels out. We get 1, so 1y, or just y. And negative 12 divided by 4 give us a negative 3. Okay, so now we have an x, now we have a y. Okay, we know for sure that it works in this equation because that's the one we just solved, but maybe we should just double check it works for the other equation. Maybe. Let me just write that equation down here. Negative x plus 4y equals negative 16. So I'm just going to take those x and y values we just found, 4 and negative 3, put them in this equation and make sure that it makes the equation true. So here, for x we have 4, so we're going to have, there we have the negative sign, and x is 4, plus 4 times y is negative 3, equals negative 16. So let's solve this. 4 times negative 3 would give us negative 12. We have negative 4 minus 12. Well, that does in fact equal negative 16. Look at us go. All right. So the final step then is to write your answer. Write solution to system as ordered pair. Okay, I'm just laughing at myself right now. Okay, so that's going to be your x and y in parentheses there. We know our x is 4, know our y is -3, and there's our solution. Okay, so there's the steps. Feel free to go back and look at this all together. Now that you can see everything we just did in one go. Take a look at that if you need to while you're doing your own stuff. If you get a little lost, you can always look back at these examples. But we're going to do one more example, and then you'll have some problems to do by yourself. That went really high. Okay, let's do this second example. So we're going to use Ninja Turtle colors this time. Okay. Hold that thought. Okay. Y equals -4x plus 2, and y equals 2x minus 4. That's an x. Okay. All right, let's zoom in and let's do this. Step 1. Step 1 is solve for one variable in one equation. What's cool about this one, you'll notice, is that we've already solved for y in both equations. We didn't even have to do anything. So check mark that. That was a really crappy check mark, sorry. Okay. So what's cool about this one is basically you can just take this quantity, since that quantity equals y is that quantity, we could substitute that quantity for y into the other equation where y is, right? If we know that 2x minus 4 equals y, and we also know that -4x plus 2 equals y, well, then it would follow that 2x minus 4 equals -4x plus 2. If you're like, what the heck just happened? Just take a look. We have a y, and that y equals this quantity. We have another y, right? Same variable on same graph, so it's the same thing. We know that it also equals this quantity. So if this y equals this y, that would mean that this equals this. Okay, so same thing we did on the other ones, we substituted some quantity in for a variable. Okay. All right, so now we're going to solve for 2 would be 2. I guess that was 2. Substitute. I want to make sure we have the steps out clear just so you guys can look back at this if you are lost. Substitute that value into other equation. Okay. Step 3. Solve for variable. In this case, we're going to solve for x because that's the only variable left in our equation. Here we go. All right. So we need to get the x's in the same spot. Again, there's multiple different first steps you could take. What I'm going to do is choose a different color. Okay. Since we have a -4x on the right, I'm going to add 4x. -4x plus 4x would cancel out. That gives us just 0. But we have to remember to add 4x on the other side as well. So 2x plus 4x, 2 of something and 4 of something makes 6 of something. And now we need to get that 4 onto the other side, right? Combining our like terms. So if we have a -4, we would want to do the opposite and add 4 to both sides. Negative 4 plus 4 is 0. So there we just get 6x. And on the right, 2 plus 4 is 6. Okay. We still need to get x by itself. Right now it's being multiplied by 6, so we would do the opposite and divide by 6. And we are left with x equals 6 divided by 6, which is 1. So highlight that information because that's important. Step 4. Substitute that value. My dog just bringing an apple inside to eat. That value into equation and solve for other variable. Okay. So let's look back at our equations there real quick. Again, you could choose either of the equations to substitute that number in for x and solve for y. I'm just going to do the, let's do the purple equation. Y equals 2x minus 4. And I'm going to put x in green, just so you can see where that's going in there. So we know that x is 1, so I'm just going to substitute 1 in for x in this equation. Here we go. And then just solve for y. Shouldn't say just. There's steps involved. 2 times 1. Right, now we're following PEMDAS because we're just simplifying things. 2 times 1 would be 2. Surprise. And simplify that. 2 minus 4 would give us -2. And there we have it. We have our x and we have our y. You can always double check your answer by substituting those values into both equations and checking. So actually, why don't we just do that? Let's do it. So we have -2. Oh, that equation is purple. Here we go. -2 for y in our first equation equals -4 times 1, x is 1, plus 2. Let's make sure this is true. -2 equals -4 times 1 would be -4, plus 2 would give us -2. So that is true. The other one, just to verify, we would say -2 equals 2 times x, which is 1, minus 4. In this case, we have 2 times 1, which is 2. If we subtract 4 from that, we get -2, and -2 does equal -2. So we are golden. So the solution then, I guess we should do step 5, huh? Right, solution as ordered pair. So the solution to those systems of equations is the ordered pair 1, -2. And there we have it. If we had graphed those two lines, this would be the point of intersection. I will struggle to say that word. Okay, let me zoom out so you can see both of those. Let me take a screenshot if you need to, so you can look back at those examples and see what happened there. Okay, now it is your turn. Wah, wah. I shouldn't say that. It's exciting. You get to solve problems. Okay, so what you're going to do on the assignment that is attached to the Google Classroom assignment that you are watching the video on is a worksheet that looks like, let me get there. Oh, there we go. looks like this. Unfortunately, I didn't have time to print it and get it to you for the Monday pickup this week, but you can print it from the attached document. If you don't have the ability to print, that's totally fine. What you can do is just rip out a piece of paper from your notebook, maybe put systems of 2 equations on the top because that's the title of this worksheet. Note that it is due Monday the 26th, so if you're an online student, you're going to be dropping it off Monday, okay, this coming Monday. If you're just an absent student, you'll turn it in when you get back. So we're actually not going to be doing those. You can do them if you want more practice with the graphing stuff. But what we're going to do today is this section right here. So you can basically ignore this today too. Okay. What you need to do is choose five problems in this section. So you could do that. You do any of those. Okay, there's, let's see, 4, 6, whoa, 10 to choose from. So you only need to do half of those problems in that section. Okay, the key thing is you have to show work. Okay, what I mean by that is basically showing step by step, just like what I did there on those examples. Now you don't have to write out what I wrote in black there. You can just write out like these steps, colored parts, okay? That's what I mean by show your work. Now, the key thing here and why I'm telling you you have to show your work or I will not grade this, and like absolutely will not grade it, is because I am giving you the answers. The reason I'm giving you the answers is so you can make sure that you're doing things correctly while you're working through the problems. And if you don't get the right answers, well, you can go back and check where you did something wrong, which is totally fine, by the way, because even I made a couple of mistakes when I was doing the key. So it's totally fine. It happens. So there's the answers to the problems. So you have to show your work. Because I'm giving you the answers. Okay. Again, those are just to verify that you did the work correctly. Okay. So choose 5 problems to complete under the substitution section. Show your work. If you print out the worksheet, don't worry about turning it in or anything yet because we're going to be working on it tomorrow too. Okay, and I mean, you probably can't turn it in anyway because you'll drop it off on Monday. So hang on to it for tomorrow though. And I might actually just pause this video. No, I'll start a new. No, I'll just pause this video for a second and move on to the elimination parts, which is for the 10/22 date, Thursday's work. That was a struggle to say. So substitution is the work for Wednesday, 10/21. Okay, so pause the video now if you want to come back and do the elimination stuff on the 22nd. Awesome. If you want to just get it all done in one go, great. Pause the video in that case, work on those substitution problems, and then come back. I'm going to pause the video too, so I can get a drink. All right, I am now sufficiently hydrated. My throat was getting a little dry. If you're just joining me for this video, you paused from the last half of the video with substitution. Welcome back. Okay, I'm not a talk show host. All right. So today, and maybe you're just continuing this and getting this all done in one day, great. If not, today you should be doing this on 10/22, Thursday. So today we are going to be talking about solving systems of equations using the elimination method. Okay. The reason I'm teaching you two different algebraic ways to do it, so aside from the graphing way, struggling, is because sometimes people think substitution is a lot easier and other people think elimination is a lot easier. So I want to make sure you have enough tools in your tool belt and you can choose which one makes more sense to you. Okay, so on tomorrow's work, which I'll talk about later, you're going to be solving systems of equations, but you can do it using any method. Okay, so it could be graphing, substitution, or elimination. And I would just choose which one you're most comfortable with, or if you want to challenge, choose the one that you're not comfortable with. So we're going to talk about elimination today. So these steps are again in your printed notes from a couple weeks ago that I gave you. If you lost them, they are posted online, or you can just screenshot this display right now, and there's your steps. So I'm going to go over this generally first, and then we'll kind of jump into it with examples. So the first step would be to write both equations so that the like terms, actually, let me highlight, so that the like terms are aligned vertically. Okay, so vertically meaning up and down. Like terms, just to clarify or remind you, it's terms that have the same variable raised to the same power. For example, you could do like 2x minus 1/2 x, or you could do 4x squared minus x squared. But you could not, for example, do 4x squared minus 2x, and you could not do something like 4x minus a constant, so something that doesn't have a variable. So those are bad. Okay, hopefully that rings a bell. Once you have done that, aligned your like terms vertically, I guess I could draw you a quick example of that. Just in general, we're going to have some x number plus or minus some y number, and maybe it's the other order, y plus or minus x, that's fine, equals some number. Okay, for one equation. Your second equation, you'll basically just line it up the exact same. Now, obviously, you probably have numbers and stuff in your equation. I'm just doing this generally. Okay, if your equation does not have the x and y on the same side as the x and y in the other equation, you're going to have to move things around. Okay, so if we had something like x equals some number minus y, you're going to have to move y to this side. Since it's negative, we would add it. And that way our y and x are aligned with the y and x in our other equations. Okay, so that's what we mean by like terms and aligning them vertically. Okay, the next step is to multiply one or both equations by a constant to get two equations that contain at least one set of exactly opposite terms. What I mean by exactly opposite terms is something like 2 versus -2, or I'll do more examples over here. Opposite terms, you could have like I don't know what I was going to do there, 4x squared and negative 4x squared. Or maybe we have just y, and the opposite of that would be negative y. So basically it's just the negative or positive version, right? If it's positive, you'll do the negative version. If it's negative, you're going to do the positive version. And you change the equation by multiplying the entire equation by some constant, okay? And I'll go over exactly what I mean by that with an example or two a little bit later. So once you have done that and you have at least one set of exactly opposite terms, so your x's are opposite or your y's are opposite, you're going to then add the equations, just like if you're doing an addition problem, right? If we had like 11 and 12, right? You would add this column and then this column, right? You would do the same thing. You would add your x's, add our like terms, right? Our x's, then you would add our y's together and our constants together, okay? To create a new equation. Okay, and again, if you did it correctly, you're going to have one set that are exactly opposite. So maybe your x's are exactly opposite, and in that case, what's going to happen is your x's will cancel out and you'll be left with just y. Okay. Once that happens, you're going to solve for that remaining variable. So maybe it already is just like y equals some number. But if it's like 4y equals some number, you're going to have to isolate the y, right? So solve for that remaining variable. And the second to last step is substitute that value in, one you just found in this step D, into one of the equations and solve for the other variable. The last step would be to write it as an ordered pair. Okay, so let's go over those steps with some actual problems. Okay, maybe I'll do it off to the other side since that side has already been taken over. Yeah, I'll do that. Okay. I guess it doesn't want to scoot over anymore. Okay. So what you'll notice is that the two example problems I'm going to do are actually the first two problems on that worksheet from yesterday, the solving of two or systems of two equations worksheet that you started with substitution. The first two problems under the elimination section, those are the examples I'm going to do. So feel free to like write out what I'm doing on your actual paper. They do not count towards the practice problems that you're going to have to do, but they'll be right there for you if you want to view them if you're stuck on other ones. Okay, so the first example problem, I guess I should write the actual number. It's number 15 on that worksheet. Number 15. All right, so let's write our two equations. 8x minus 6y equals negative 20. And our second equation, actually, let's do, what just happened? Sorry. Freaking out. Okay, we're good. I just wanted to change this color to orange, so it's Halloween colors. Okay. Negative 16x plus 7y equals 30. Okay, so step one is to vertically align like terms. My handwriting is awful today. Oh well. Okay, so if you look at our two equations, you'll notice that our like terms are actually already vertically aligned. So that step was done for us. Step 2, it won't always be done for you, but in this case it was. Step 2 is to multiply by a constant to get opposite terms. Okay, so if we look at our two equations here, we have, let's just look at the x's and the y's and the constants. We have 8x and 16y. That would be fairly easy to get to the same number, okay? The same multiple, if you will. If you look at the y's, we have negative 6y and plus 7y. That one we could still do. It would just give us some big numbers. So the x's, in my opinion, are going to be easier to convert into opposite terms. So what you're going to do is find some multiple. It could be the least common multiple or just any multiple that both of them go into. So just a common multiple, and figure out how you need to get one of those equations so you have an opposite term. That sounds very confusing, but let me just, I got you. So if you look at our x's, because that's what we're going to change, we have 8x and we have negative 16x. So we know that we want opposite signs, meaning positive and negative, which we already have, right? The 8 is positive, the 16 is negative. So we're good there. We don't have to multiply by a negative number to make things negative or anything. But we do need to multiply 8 by something to get to 16, right? Because we want the exact opposite of this. We want to get to positive 16, okay? The exact opposite of 16 is, sorry, I meant to do positive there, would be negative 16, okay? So we're trying to get to 16. What do we need to multiply 8 to get to 16? Well, think back to your multiplication tables. We multiply it by 2. If we multiply it by 2, we would get 16x, which is the exact opposite of negative 16x, okay? So now that we know what we need to multiply by, we're going to take that constant, the winner, chicken dinner constant, and multiply that entire equation, so each term in the equation, by 2. Okay, so let's rewrite it. We're going to have 2 times this entire quantity, 8x minus 6y equals negative 20. So yes, you're doing it to both sides of the equal sign. Basically, we're just distributing that 2 to what's inside. So we have 2 times 8x, which we already know gives us 16x. And then we have 2 times negative 6, which would be negative 12y. And then 2 times negative 20 would be negative 40. Okay, we draw a little line there to separate. Should have just done it in a different color. Oh well. Okay, now I'm going to write the other equation under it so it's all vertically aligned again. And there we have it. We have our x's vertically aligned, our y's vertically aligned, and our constants vertically aligned. Now we're going to do step 3, which is to add. I'm actually going to write it to the side so I don't have to rewrite this whole thing. Step 3 is to add equations. What I mean by that is add like terms to create one equation. Okay, so let's add these. Think of it as just like a big addition problem, right? We're gonna add our columns. So 16x minus 16x, well, that cancels out and gives us 0, right? So we can just leave that part blank. Next, we would have negative 12y plus 7y, and that would give us a negative 5. Let's do this what do orange and green make? Brown? I'll just do purple. Okay. The things I worry about. Okay. Negative 12y plus 7y is negative 5y. Okay. And next we would have, oops, sorry, I forgot to add my constants. Whew, that was a close one. We have negative 40 plus 30. That would give us negative 10. That was a close one, Monson. Okay, so I caught myself. We're good. Step 4. Step 4 now is to solve for remaining variable. In this case, we're solving for y because that's the only variable left in the equation. Let's get this down a little bit. So to isolate y, maybe I'll just rewrite it down here so we have a little more space. To isolate y, it's being multiplied by negative 5 right now. So we want to divide by negative 5. On both sides, right? Because we got to keep that balance. And now we get y equals, sorry, my mama's calling. Y equals negative 10 divided by negative 5 would give us a positive 2. Positive 2. Okay. I have to pause this for just a second again. Okay, I swear that's the last time I'm going to pause it. I think I just jinxed myself. Okay, where were we? Step 4. Sorry, there was a crumb on my screen. Okay. No, I was not just eating something. I don't know how it got there. Something on my screen. Okay. So we finished step 4. We solved for that variable. Step 5. Step 5 is to substitute that value into equation and solve for other variable. Okay. Sorry, I was laughing at how slow I talk while I'm writing. Okay. So we know that y equals 2. So you can choose either of the equations that we started with to, not the manipulated one, but the original equations we started with. So these ones right here. To substitute 2 in for y and solve for x. Okay. Either one's totally fine. I'm going to choose the green equation. So we have 8x minus 6y equals negative 20. So there is our original equation. I'll zoom back out when we're done so you can see the whole thing we just did. But okay, so we know what y is. We know that y equals 2. So we're going to substitute 2 in for y in this equation. So we have 8 times x minus 6 times y, which in this case, y is 2, equals 20. And now we solve for x. The first thing we'd want to do is get rid of those parentheses. So we need to multiply 6 times 2. That would give us 12. Everything else stays the same. Okay. To isolate x now, we need to get rid of whatever is being added or subtracted from the x term. In this case, we need to get rid of this, negative 12. To get rid of it, the opposite of negative 12 would be positive 12, so we need to add 12. And whatever you do to one side, you have to do to the other. Negative 12 plus 12 is 0. So we are left with 8x on the left, and negative 20 plus 12 on the right would give us negative 8. Now we're still not done. We need to get x totally by itself. Right now it's being multiplied by 8, so we would do the opposite and divide by 8. A little bit more space. Leaving space. Okay. 8 divided by 8 is 1. 1 times x is just x, so we have x on the left. And then negative 8 divided by 8 would be negative 1. And there we have it. We have an x value and a y value that make both equations true. And again, you can double check that it makes both equations true by substituting both those numbers into the other equation and solving. Okay. The last step again is to write solution as ordered. I lost track of what I was writing there. Okay, you know what I mean. So our x for our ordered pair is negative 1, and our y was 2. There's the solution to this system of equations. Awesome. So if we were to graph those two equations, that is the point where they would intersect. It's the only two values, the only value of x and y that make both equations true. Okay. We're going to do the second example slightly quicker, just because we've gone through it step by step now, so hopefully we're getting the hang of it. The next one we're going to do, again, it's the other top equation on the solve each system by elimination section on that worksheet. So it's number 16. Number 16. Okay. Numero 16. Let's do a blue equation. Okay. Let's write our two equations out. 6x minus 12y equals 24. And our second equation, let's do purple. Let's do red. Okay. Negative x minus 6y equals 4. Again, step 1 is to vertically align. I'm not going to write the steps out this time, but step 1 would be to vertically align our like terms. Our like terms would be our x terms, our y terms, and our constants. Lucky for us, they're already vertically aligned, so we're good there. Now we need to figure out how to multiply one of these equations so that either our x values are opposite or our y values are opposite. You can choose either one. In this case, it would be pretty simple for either. With our x's, we have 6x and negative x, so we don't need to change the sign at all. We just need to get that red x to a 6x, negative 6x. Okay. In that case, we would multiply, right? If right now it's remember it has that invisible 1 right there. Right now it's a 1, a negative 1. We need to get it to negative 6, so we would multiply by 6. Okay, so that is one option. If you look at our y's, we have negative 12y and negative 6y. So in this case, we would need to change the sign so that one of them is positive. In that case, what we could do is multiply this equation by a negative to get it to a positive, right? Negative times a negative is positive. To get from 6 to 12 with multiplying, well, we'd multiply negative 6 by a negative 2 to get a positive 12y. Hopefully that wasn't too rambly and confusing, but I wanted to show you both options there. You can choose whichever one you want to do. What do I want to do? What do I want to do? Good question. Trying to think what I did before when I was writing the key. Ugh. Let's do our Y's. Let's do the Y's. Yeah, so we're going to want to cancel out the Y's. So we want our Y's to be, we want our Y's to be opposite of each other. Okay, and let me just write them out right here. We have negative 12y right now and a negative 6y. We want to get that negative 6y into a positive 12y. So how do we get from negative 6 to positive 12 with multiplication? Right? If you're not sure, what you can do is the opposite. So divide 12 by negative 6 to get the answer. You might just know it off the top of your head though, because I just went over it. Negative 6 times negative 2, right? 6 times 2 is 12, a negative times a negative is a positive. So if we multiply by a negative 2, we would get positive 12, which is opposite of negative 12. So what we would need to do then, since we now know the number we need to multiply by, the constant we need to multiply by, we have to multiply the entire equation. This entire equation, we need to multiply it by negative 2. So let's write that out. We have negative x minus 6y equals 4. And I'm writing things out like step by step by step, like baby steps. When you're doing this by yourself, you don't necessarily have to write out like this part. Like, you can figure that out and then just write out what you're multiplying by in the next step. Right, so there's ways to shorten this and not take up so much space. I'm just kind of making sure I do it baby steps so we're not losing anyone. Okay, so we are going to, let's do yellow. We're going to multiply that entire equation by negative 2. So each term, looks like McDonald's. Sorry. We'll go Christmas. Multiply this whole equation by negative 2. So each term we are going to multiply by negative 2. Okay. In this case, we would end up with negative 2 times negative 1x. Remember that invisible 1 there. Negative 2 times a negative 1 would give us a positive 2. Negative times the negative is positive. Then we have negative 2 times negative 6y. Well, negative 2 times negative 6 would be positive 12y. And then negative 2 times 4 will give us a negative 8. All right. Now that I have my modified equation, I'm going to write the other one beneath it with our like terms, vertically aligned. And from here, I just put a line so we can kind of signify an important step here. From here, we're going to add both of the equations. We're going to add them together. We're going to add our like terms. So we're adding our x's, we're adding our y's, we're adding our constants. Okay. All right. So 2x plus 6x. They are like terms because they're the same variable x raised to the same power 1. So 2 of something plus 6 of something would give us 8 of something. Negative 12y minus 12y, well, that would give us 0. So that cancels out. On the right side of the equation, we have negative 8 plus 24. Negative 8 plus 24. That would give us 16. 16. Now we solve for x. That's the only variable left, so that's what we solve for. In this case, x is being multiplied by 8. So to get rid of it, we would divide by 8. And again, quick reminder, if you're totally lost on how we're solving equations, please go back and refresh your memory by watching one of those how to solve equations videos that we've posted before, that I've posted before. Okay. Anywho, 8 divided by 8 would give us 1. 1 times x is just x. 16 divided by 8 would give us 2. So we now have our x variable. We can take that x value and substitute it into one of the original equations, one of these ones, and solve for y. Again, it doesn't matter which equation you choose to substitute x in and solve for y, because it will work with both, because it is a solution to both of the equations. Okay. Let's maybe do the blue one. So I'm going to rewrite it. 6x minus 12y equals 24. So we're going to take that value for x and substitute it in the equation. So now we have 6 times 2 minus 12y equals 24. So y is the only variable left. We're going to solve for y. 6 times 2 would give us 12. Nothing else changed. I keep wanting to write like a different number for my 2's, which is why there's that weird line on the top of them. Okay. Solve for y. Let's do this. We need to get the like terms, or constants, on the same side. To do that, 12 is positive right now, so to eliminate that, we would need to subtract 12. And 24 minus 12 would give us 12. Now we have negative 12 times y equals 12. So to get rid of that negative 12, we would divide by negative 12. Don't forget that negative sign. That's where a lot of people get tripped up. Don't forget the negative sign. So negative 12 divided by negative 12 would be 1. So that just basically cancels out. You're left with 1y, or just y. And 12 divided by negative 12, well, 12 divided by 12 is 1. And a positive divided by a negative is a negative. Now we have our y value. And again, you could substitute that x value and that y value into the second equation and solve, just to make sure that it makes a true equation, to make sure you got the solution right. Because that ordered pair here of 2, negative 1 is the only solution to this system of equations. And there we go. Hopefully I'm not confusing you too much. Again, some people like elimination a lot better than substitution, and some people like substitution a lot better, right? They both work perfectly fine. So let me zoom out so you can just kind of see the whole problem we did while I talk. You're going to do some practice problems now on that worksheet that we started yesterday, or if you're doing this all in one go, the worksheet you did earlier. Now you're going to be working on elimination problems only. So you're not going to use substitution at all. You're using elimination for all 5 of the problems you're going to choose. If you get stuck, please go back and look at these example problems. Hopefully you're writing them down on that worksheet, since they're on that worksheet, just so you have something to reference. If not, you can look back at this screenshot right here, maybe take a picture, or you can also go to that page in your notes that goes through the steps, and hopefully those steps make a little more sense now that we've walked through problems. Okay, so what you're going to do for the practice. What's that song? Practice, practice, practice. You know what I'm talking about? What is that from? Oh, Swan Princess. Oh my goodness. I have not thought about that movie in a long time. Decades. That's hilarious. Okay, I'm getting distracted. So to practice solving systems of equations using elimination, you're going to use that same worksheet you started earlier. You're now going to choose 5 problems to complete under the elimination section, and you're going to complete the critical thinking question at the bottom. Okay, so 2 parts there. Again, you have to show your work because lucky you, I gave you the answers. So that way you know while you're solving these that you're getting them right, and you're doing things correctly. And if not, you can go back and check what you did wrong and learn from our mistakes. So let me show you the worksheet. So it's this same worksheet, and now I can kind of get rid of some of those marks on there. So we're not doing substitution anymore because that's what you did earlier. So you should be done with 5 of those problems. You still don't need to do the graphing ones unless you want more practice, which awesome, good for you if you want to. What you're going to focus on for today, oh psych, okay, today 1022 is this section right here. Solve each system by elimination. Okay. Again, this worksheet is posted on this assignment on Google Classroom. So if you didn't print it, it's fine. You can just open it and then on a separate piece of paper, write solve each system by elimination at the top with your name and then the problem number and show your work. Okay. So if you didn't print it, it's totally fine. So what you need to do is choose 5 of those problems. Now, you'll note that we already solved that one and that one. So you cannot do those ones again. They do not count towards your 5. So you need to choose 5 other ones. So at the end, out of this section, you're going to have a total of 7 problems in that section done. Okay, so those 2 that we did together do not count towards your 5. And if you didn't watch the video all the way through, I feel bad for you because you won't know that and you'll have to go back and do more problems once you turn it in. So hopefully you're watching this. If you are, pat yourself on the back. Good job. Okay. So again, choose 5 of those problems, just not the ones we already did. And you also need to complete this critical thinking question. Now, let's take a look at it really quick. It says, write a system of equations with the solution for -3. So you need to write 2 equations that have the solution for -3. So that means that the number 4 for x and the number -3 for y, those 2 numbers, when substituted into both equations, will be true. Okay, I'll give you a hint. It's a lot easier to work backwards sometimes. So like starting with x equals 4 and building from there. So maybe you multiply both sides by 2 and you get 2x equals 8. And then maybe you can subtract y from both sides and get 2x minus y equals 8 minus y. And then maybe multiply again or divide or whatever you want to do. Okay, so that's one way you can think about writing equations with specific solution. The other way is you can grab a graph, right? Plot that solution, so 4, -3, somewhere right there. And then just maybe draw 2 lines and find the equations for those lines. So y equals some slope times x plus some y-intercept, right? So 2 ways. I personally like the graphing way better, but again, people do things differently, and that's totally fine. Tiger, you're okay, girl. Oh, Rubio. I don't know if you can hear my other dog whining. It's hilarious. Okay, so I'm not going to help you with that critical thinking question. That's one you need to struggle on. So if you have a question on that, if it's a clarifying question, I will answer it. If it's a I don't know what to do, I'm going to let you struggle because struggle time is good. If you have questions on the other ones, though, the solve each system by elimination problems, please either email me or contact me on Google Hangouts, or we can meet on Google Meet, whatever works best for you. Okay? So, wow, this is messy. So, by the end of these 2 parts of this video, so the solving system of equations with substitution and then with elimination. This worksheet right here, you should have a total of 5 problems in the substitution, 5 in the elimination, plus the critical thinking. So you're going to have 11 problems done. And you're welcome to do more. Obviously, you're welcome to do more for practice. I always encourage that. So you'll have 11 problems done, and it is due Monday the 26th. So if you're an online student, you need to bring it with the Monday drop-off pickup. If you were absent on 10/21 or 10/22, you'll just need to give it to me when you get back. Okay? So if you have any questions while going over this, please contact me. Okay? We're only going to get more complicated with equations, so I want to make sure that you all understand these stepping stones to where we're getting. Okay? All right. Good luck. Oh, no. I'm not going to go over that. We'll just go over that in a post. Okay. Scratch that last part. Okay. Good luck, you guys. Let me know if you have any questions.